Let's see how much silver's really on this stuff. A couple hundred years ago, someone figured out that it was cheaper to make stuff out of copper with a thin layer of silver than it was to make things out of solid silver. Then in the 1840s, someone else figured out how to do it even cheaper by adding the thin layer of silver using electricity, which is how most of the silver plate you'll find at garage sales and thrift stores was made. Today, I'm going to work on a way to get the silver back off and figure out how much is really on there. For this test, I'll use 100 pieces, trying to get a good mix of sizes, styles, and ages in order to get a good idea of what to expect on average. Look at this guy. With my pile picked out, a mixture of 95 parts concentrated sulfuric acid to 5 parts concentrated nitric acid is added to an old Pyrex bread pan. I got this recipe from a restoration shop that uses it to strip the old plate before replating older items. The silverware is then added to the dish as the acid heats up. The silverware will initially turn bright white as the surface oxidation is dissolved, and then, depending on the base metal, go to a dull gray or yellow as the acid dissolves the silver plating. The pieces are pulled from the dish and transferred to a rinse bucket as they're stripped, with the amount of time varying depending on the thickness of the plating. Some manufacturers actually put extra silver on the bottoms of forks and spoons, as this would be the first spot to wear off from use. The process is then repeated. About halfway through the batch, the solution changed color from green to purple and started foaming. This is an indication that it has run out of nitric acid and more needs to be added. After adding more nitric acid, the remaining silverware is processed, and the solution is cooled and added to a bucket along with all the rinse water. To get an idea of how much silver is in solution, a few drops of hydrochloric acid is added to a sample taken from the bucket. Looks pretty good. Next, a saturated saltwater solution is added to the bucket to convert all of the dissolved silver to insoluble silver chloride. After a good stir and some time for the silver chloride to settle out, a sample is tested with hydrochloric acid. An absence of white precipitate indicates that all of the silver has dropped out. The barren solution is then drawn off and the solids are transferred to a smaller container and left to settle out. Here you can see that the outer layer has darkened due to exposure to light. The remaining solution is filtered out and the silver chloride is washed with clean water several times to remove the residual acid and any dissolved base metals. The clean powder is returned to a beaker and a few spoonfuls of sodium hydroxide is added. The sodium hydroxide will convert the white silver chloride to black silver oxide. It is added a little at a time with a lot of stirring and is continued until additions no longer cause a color change. Glycerin is then added slowly, again with plenty of stirring. The glycerin will reduce the silver oxide to silver. Here you can see a thin layer of silver coating the inside of the beaker as the reaction starts. The addition of glycerin has to be done slowly, as the reaction can actually generate enough heat to run away and boil over. When the powder quickly settles out and no longer changes color with additional glycerin, the silver oxide has been reduced. At this point, the liquid is filtered off and the powder is washed several times with hot water. Washing is continued until the pH is around 7. The powder is then dried before melting. The silver is pretty fluffy at this point, so only half of it is loaded into the crucible. After partially melting the first half, the second half is added, melted, and poured into a graphite mold. And here's the final ingot of silver, which, along with the drop that splashed out of the mold, weighs a total of 114 grams. At today's price of 76 cents per gram, this comes out to $86.64 worth of silver, or about 86 cents per utensil, which is a lot more than I was expecting. I should note that this experiment was done with common patterns and mostly beat-up material. I did set aside all the older stuff for interesting patterns I found while digging through the pile.